Hello everyone. So today's topic is about Hess's law. So we have to find the standard enthalpy for a reaction. So what I've done is I've written out our target equation in white here. So we have carbon solid plus half O2 gas produces carbon monoxide gas. So just a heads up, so states do matter for these types of questions. And essentially what you're doing is just solving the delta H for this reaction. Now you're given two equations, and what you have to do is you have to manipulate your two given equations to match the target. So pretty much when we're done, we need to make sure we have carbon solid, oxygen gas on the reactant side, and on the product side, carbon monoxide. All right, so let's use, so we need carbon solid, oxygen gas. So looking at our two givens, our first equation has what we need. So let's use equation 1. So we have carbon solid plus oxygen gas produces carbon dioxide gas, and delta H equals -394 kilojoules. All right. So we also need to get carbon monoxide on the other side, on the reactant, on the product side. So looking at these two equations, our second equation gives this to us. So let's write this out. Something I like to do is that I like to line up the arrows, and this will help with your calculations. So we have CO2 gas produces CO gas plus 1/2 O2 gas. Delta H equals positive 283 kilojoules. All right, so from here, let's see if when we cancel out the compounds, what do we get? All right, so canceling things out. So carbon dioxide cancels here, and we have half of oxygen here, which cancels out with one whole oxygen. So that means that you're going to have 1/2 left over. So overall, after canceling things out, we have carbon solid plus half oxygen gas produces what you have left over, carbon monoxide gas. Does this match our target equation? Yes, it does. So from here, we add the delta H values, and after you add it together, you get delta H equals -111 kilojoules. All right, so for this next equation, we have to get everything to match our target equation of CO gas plus H2 gas plus O2 gas produces CO2 gas plus H2O gas, and we have to find the delta H value. So the first thing I see is we have carbon monoxide, and in our target equation, there's one of them, and it's on the reactant side. So what we can do is we can use our first equation here, and we can flip it. And not only do we flip it, but we flip it and we divide by 2. So dividing it by all the moles by 2, we had 2 CO in our equations. Now we have 1 CO. We had 2 carbon solid. Now we have 1, and we had 1 O2. Now we have half. And if we flip it, we have to reverse the delta H value. And since we divide everything by 2, this is also divided by 2 as well. So that's how we're going to get positive 111 kilojoules. So that's dealt with. So next, I see that there is a carbon dioxide, and our second equation also has carbon dioxide. So I'm going to leave that one as it is. So that means that we have carbon solid plus O2 gas produces carbon dioxide gas, and the delta H, since we are just leaving it as is negative 394 kilojoules. And for the third one, I see that there is one hydrogen gas, and in our given equations, there's 2 moles of it here. So what I'm going to do is I'm going to divide everything by 2. So this means that I'm going to have H2 gas plus half O2 gas, because I divided everything by 2, and this will produce 1 H2O gas. And since I divided everything by 2, that means our delta H value is going to also be divided by 2. So we have negative 242 kilojoules. All right, and from here, let's see if they cancel out. So, carbon solid cancels out, half O2 cancels out, and let's see what we have left over. Everything else here is good. Okay, so let's see. So we have carbon monoxide gas, and that's good with our target. We have hydrogen gas, and that's also consistent with our target. We have O2 gas left over, which is also consistent with our target. Produces carbon dioxide gas, which is good. That's consistent with what we need. And we have H2O gas, which is also what we have. So from here, we're going to add up all the delta H values. After you add it all up, you should get negative 525 kilojoules. Alright, so for this next equation here, we have our target equation of CO2 gas plus H2 gas produces CO gas plus H2O gas, and we need to find the delta H value. So first thing I notice is I want to solve the CO2, and in our given, CO2 is on the product side, so I'm going to flip it, and by doing so I get CO2 gas, and on the other side I'll get copper solid plus O2 gas, and since I flipped the equation, the delta H value is going to be opposite. So instead of positive, it's going to be instead of negative, it's going to be positive 394.90 kilojoules. Next, I see that I want carbon monoxide on the other side, and in our second equation, it has already given this to us, so that's perfect. So let's leave it as is. So we get copper solid plus 1/2 O2 gas produces carbon monoxide gas. Delta H equals negative 110.94 kilojoules. And then for our third one, I see that water, so H2O gas is already on the right side, and also H2 gas is already on the left side. So for this one, we'll leave it as is as well. So we get H2 gas plus 1/2 O2 gas produces H2O gas. Delta H equals negative 242.76 kilojoules. And let's add it up and see what we get. All right, so let's try to cancel some of these things out. So we have copper solid, gone. We have half and half O2, which cancels out with one whole O2. Great. And from here, I believe we should have our final answer. So CO2 gas, check. Plus H2 gas, that's good. So we're trying to match our target equation. produces CO gas, that's good. CO gas. And H2O gas, great, that's good. So now that this matches, now we add up the delta H values, and by doing so, we get 41.2 kilojoules. So other words of advice, how do we know what to manipulate? Well, you try to match the target equation and its compounds. One way is you're pretty much using trial and error if you don't see it right away. Remember that you can flip the equations as needed, but make sure you change the delta H value if you do. And if you multiply the coefficients if needed, make sure you change all the coefficients and also the delta H value.